All right, cool. All right, well, thanks again for everybody joining. This is, I believe, our 8th or 9th session. Man, I'm losing count, but this is fantastic. I really appreciate everybody joining these. So today, we got Jesse from Austin, Texas. He's the CEO and co-founder of Chef Secure. He's also a guest lecturer at the University of Texas at Austin for cybersecurity and software engineering. So very, very excited to have him. And Jay, thank you again for introducing me. I really appreciate it. So what I'm going to do is, if you guys have questions, definitely throughout the process, ask it in chat. And then also just kind of feel free to raise your question or raise your hand during it. And then also, I'm going to make Jesse the host. So Jesse, just do me a favor, keep an eye on people in the waiting room once it kind of pops up and just let them in throughout. And then we'll kind of open it up for questions at the end. Cool? All right, well, thanks again for everybody joining.
All right. So I'm going to wait to be made the host, or are you going to do that
I'm doing it right now.
Okay.
There you go, buddy.
All right, cool. So, hey everyone, I'm Jesse from Chef Secure. And today I'm going to be talking to you about unethical hacking. And so normally the usual spiel is you get somebody from security talking about how hacking, it's like you're not supposed to do X because of theoretical danger Z. And if you don't really understand, what theoretical danger Z is, it's not very helpful. So it's like, okay, buddy, thanks. I'm going to get back to work now, and then I'm going to avoid you until the next required meeting. And that's usually why there's a lot of tension between security and development, is because we're not speaking the same language, because we're kind of keeping things away from developers. Just because, we try to avoid talking about what are the unethical things that can happen. And so today I'm going to be talking about some of those things, and I'm going to share with you an exploit that we're going to be going through. We can go through it together if you want to follow along, or you can just go through it afterwards. I'm going to send the links out later on, just so I might be rushing through this to make sure we can cover everything. But with that said, the reason I'm doing this is so that you can effectively prioritize whatever issues come in. Like if you have a security issue come in and you're grooming your backlog, or you're doing your sprint planning, or there's a security issue on your Kanban board, how do you prioritize that with all the other work that you have going on right now? And the reason is, like, you need to think about it from the business perspective, not just a security perspective, not just a development perspective, because it's all about the business. Like, is the business going to survive if the security issue isn't fixed? Or maybe you have like a bug that's more important than a security issue. And I'm going to be, blasphemous right now to security and say that security issues are not always #1 priority, because, like, again, it's the business needs. And so with that said, I wanted to give you the full perspective of, what are some of the worst things that can happen. And I'm going to be going over cross-site scripting vulnerability. And a lot of people seem to think that, that's kind of a dead issue. But in fact, like, modern frameworks that do have automatic XSS protection, like React has been around for over 7 years. And then server-side frameworks with automatic XSS protection have been around for over a decade. And yet it's still the #1 most commonly found issue by security researchers. Like, if you look on HackerOne statistics, you'll find so many XSS vulnerabilities. And that's just because, one, it's kind of tricky to get it right all the time, because you don't know where all the untrusted input's coming from. And so I'm going to show you kind of what happens when a vulnerability gets exploited. But with that said, like, this isn't just about cross-site scripting. It's really about thinking in the mindset of an attacker, thinking in the mindset of a criminal hacker who would want to do bad things. And some of the things are like you might be thinking, my application, it's not that important, maybe. And so you just have this tiny, maybe it's a side project you're working on, or maybe a professional app that isn't, like, you don't have millions and millions of users or billions of users that you're working on. And so it's not really a big target. But in fact, attackers don't care. First of all, they have, scripts, they have bots that are running, just trying to go through and crawl the entire web and find vulnerabilities and just find applications that they can exploit and take over. And that can become part of their botnets. So that's just a collection of computers. They can be like hundreds or thousands, tens of thousands of computers that they use for malicious reasons. So they can attack government systems, for instance. They can attack hospitals. or they can attack other critical infrastructure. They can use it to spread child pornography. They can use it to steal credit card information for identity theft. And just the list goes on and on. So even if you don't have that like passion within you to, oh, learn this security thing, to fix this hole in this code, at least we can all, I'm sure we can all get together and think that, hey, it's our personal responsibility. If we're putting these applications that are powerful out on the web, we need to lock them down so that these people who want to do these bad things won't be able to do them. And so I'm going to be going over next the attack, but first I want to talk about the legal implications of it. So first off, this is the standard disclaimer, you know, don't do this because it could be, it is illegal if you do it somewhere else that you're not supposed to. So you have my permission to use it on my attack server, on my vulnerable website, but otherwise you'll need permission from the application's owner in order to actually exploit a vulnerability. So there's somebody in prison right now, his sentence was 20 years and a day that he was sentenced for in prison for hacking related crimes. And you know, it's best that you don't join them, of course. And so let me share my screen and we can jump right in. And this is going to be an example from an XSS course that I created. If you're interested, like you can go through ins and outs of XSS, from attacks to exploits, fixes and prevention. That's at chefsecure.com. And I can send a link out to that later after this presentation, but let's just jump right in first. All right. And so what we see right here, this is an awesome webpage. What's going on is there's so much content on here. And what is going on is there's a vulnerability in this page. All right. And I'm just going to share that with you right now, just for time. It's right at the very bottom, the share this page link. This is what's vulnerable. And so let's just inspect to see what's going on. We have a data URL that's creating this element. It's a small element, has a data URL set to the current URL. Now, as an attacker, I control the URL. I can append different things at the end to add my own code to try to exploit the site. And since I told you already it's vulnerable, let's try to exploit it right now. So first off, let's go back and inspect that again. We can see that it's in the data URL. And just as a refresher, just so we can get the fundamentals, the basics down, HTML attributes are set using a name, an equal sign, and then a quoted value. So in order to break out of this, we need to break out of this extra quote at the very end. So we need to add a quote, and then we can add our code inside. So let's just see how that would work. All right, one of the standard attacks you see is adding an on-click event handler. So if I add on-click equals quote alert, there's still that remaining quote since we broke out of the data URL. So if I hit enter, actually I need to add a hash on the end because remember we need to stay on the same web page. And so when you add a hash on the end, we can stay on the same web page and then add as much as we want after that. So if I do that, click on share this page, you see this alert come up. This is our attack. And this is where most security lectures stop. This is where everybody doesn't want to go into the dangers, doesn't want to go into what are the bad things that can happen. And today we're going to go through that together and I'm going to show you. So let's first look at technically, like, how does this work? Again, like I explained, we closed out the quote in the data URL attribute. Then we added an on-click event handler, which is just whenever you click the element, it's going to trigger our attack, which is the alert. Now, instead of alerting, let me just show you an exploit that we can do instead. And this is actually something that's been used by attackers to exploit cross-site scripting vulnerabilities because it is very simple and it works. And so why develop some crazy complex attack with JavaScript when you can just do something like this? I'm going to inject it and I'm going to click share this page. And you have this critical Chrome update. An important security fix is required to continue. And you can download now. And what this would do is it would download ransomware to your computer. It would lock all your files, encrypt them, and then you'd have to pay like $1,000 worth of Bitcoin in order to unlock them. And so like this isn't super complex. Like it requires some trickery. It requires somebody to click that download button and install something on their machine. And the reason, like, we see this kind of happening a lot, yet it's not the most sophisticated attack. It's just because people fall for it. But let's see what can actually happen because we have the power of JavaScript And with JavaScript, that means we control the entire web page. So let's see something that doesn't necessarily involve as much trickery, because a lot of you are smart and you're not going to fall for this. Or maybe you will, I don't know. So let's go back to our alert. And I'm going to refresh the page. Okay, and then you see when we click share, it's going to launch our alert as before. And so our goal right now is, like, as an attacker, what we want is to guarantee that this will work. We want to guarantee that our exploit is going to be triggered, it's going to run, and we're not going to rely on that extra step of the user having to scroll all the way to the bottom and clicking share this page. So since we control the web page, we also control HTML and we control CSS. So we can add styles to this element to make it bigger. So let's place it, instead of having it on the very bottom, let's move it to the very top. You can do that with the style attribute. And we're going to add position fixed. And what position fixed does is it allows you to set the element anywhere on the web page. So we're going to add it to the very top, like I said. So we'll set the position with top 0 and then left 0 as well. Hit enter. And you can see right now, share this page is now at the very top left of the page. When I click it, it's going to launch the attack. It's going to launch the alert. And then if anytime I scroll, it's always going to be there. So it's stuck there. That's what position fix does. Now, still, it's very limited. Like if I inspect this, I can see it's only 93.19 pixels by 15 pixels. You know, that's very small. So we, again, have the power to change that. So let's just set the width to 100% and the height to 100% also. And with the URLs, we have to encode the percent character just because the URLs will treat it differently. And so I'm just going to tell you right now is %25. And I can show you that also. 25 is just the hex code of the percent character. And you can figure that out easily in JavaScript if you open the console and just type encode URI component. And then you can get it for any character. So I'll type in % here, and it's going to be %25. So if you're using a special character in a URL, that's why you'll see sometimes a URL has a bunch of % symbols and then a bunch of other numbers. It's because it's URL encoded. So this URL encodes it. I'm going to hit enter. Now you can see, share this page is covering the entire page. So like if you look at my cursor, it's the little clicky clickaroo. Whenever I click anywhere on the page, it's going to launch our alert. Okay, so I just clicked on the left, now I'm going to click on the right, and it still triggers our alert. Now, this means like anywhere they click on the page, then it's going to automatically trigger the alert. But this still isn't quite where we want it to be. Like we can be more evil than this. And so we don't want to have to rely on the user to click the page, because this page has a ton of content and maybe nobody's even going to click anything. Maybe it's just like, hey, I'm going to read this web page and then I'm done. I'm going to X out of it. And so what we can do instead is change the event handler, because we have access to all of those as an attacker. So let's change that to on mouse over. So anytime somebody puts their mouse on the page, it triggers the attack. Now, if you can imagine, you click a link and go on the web page, your cursor is probably going to be somewhere on the web page. So if I just refresh the page, you see that it pretty much automatically gets triggered. All right, so anytime you move the mouse, it's going to trigger the alert. And so as an attacker, this is awesome because, you know, our attack is almost guaranteed to work. And so what I want to go over now is take it to the next level, take it to the next step and see what else we can do that's unethical. One of the things is, see, it triggered it again. My attack is too good. One of the things is, how many of you share your password in your browser or save your password in your browser? Like I am one of them. Like I store my password in my browser because it helps me out. It's very convenient. So I don't have to remember my passwords and I don't have to reuse my passwords. So I can make them more complex. I can make them better, and I can use a single password for a single website and then new passwords for new websites. All right. So on here, if you're following along, or you can do it later, playground.insecure.chefsecure.com/password. This is where you can set a password. I've already saved it in here. My username is hello. My password is world. And so the password is saved in my browser. So you can see that it auto-filled in this login form already. And this is exactly what we're going to be exploiting next. All right, so the way to do that is first we need to make a login form so we can steal it. And so this is the kind of how the browsers work. Whenever it sees a login form on a web page where you save the password, then it will automatically fill it in. Now, I'm gonna take a break really quickly right here just to check the waiting room to see if there is anybody in there. And let me see if I can find that before we actually make this exploit. I'm not quite sure how to do that. Okay, there's somebody in here. Let me bring them in. All right, cool. And let me go back to sharing my screen. All right, so now let's exploit this. Keeps alerting. All right, so I'm going to first create a form element because that's what we need. We need a login form. So we'll do that with f equals document.create elements form. So we create the form. Next, we need to create the username and password inputs. So I'll have u equals document.create, misspelled document. Document.create element input. And then u.set attribute type is text. And this is just the standard input that you normally receive. So basically we're duplicating the login form. And then u.set attribute name is username. All right, and we're gonna do the exact same thing with the password. And we'll paste it in there. Update the name to password. Type is password. And then we're gonna call this one P for password. Update this one and update this one as well. All right, so now I'm going to refresh the page. I'm gonna mouse over the page and then look at the very bottom. Oh, first off, I actually need to add this to the page. So I created the form, the username and the password. Now I need to add those to the form itself. So f.append child u. So I add the username to the form, and f.append child p. I add the password to the form. And finally, we need to add the actual form to the web page itself. So document.body.append child f. We add the form to the page. All right, and I'm gonna mouse over. And look at the very bottom of the page, there is this these inputs, hello, and then the password is filled in, which is world. And so we have injected the form, the login form into the page. Now our goal next is to steal it. All right, so the way we do that is first I need to get a server listening so I can set it up. And so attackers would have, all kinds of servers. And again, this could be a server from your application that they had stolen. And I think I have somebody waiting. Oh, I have a chat. Okay, yes, it's very evil, Jay. And so what we need to do is have our attack server, have our evil server set up. What I'm gonna do is start just a localhost server on port 8000. So I'm running a server and now I need to make it accessible to the web. And I'm running ngrok to do that. So first thing I'm gonna do is copy this HTTPS URL and go to the end of the payload. And so here's a caveat with Chrome. In Chrome, you have to actually interact with the page. You have to click the page before you can access the auto-filled values in JavaScript. Firefox, you don't have to. Safari, I don't believe you have to either. And so this is just an extra step for Chrome, but it's not a major issue because most likely somebody's going to be clicking somewhere on the page. And so we need to add an event listener for listening to clicks on the entire web page. So we can do that with document.add event listener, and we're going to add click. So whenever somebody clicks the page, we're going to run some more code. So we'll add a function in here, and then we're going to do a fetch call. So this is just a URL request. This is just an HTTP request to a URL. Now, all of this code that we've typed so far, this isn't something super advanced. And so keep that in mind. Like whenever an attacker can exploit an application, it doesn't really take a whole lot of advanced skills to be able to exploit it and to be able to cause a lot of damage. Because right now we're just using some basic standard JavaScript. And so what I'm going to do now is put that URL inside template literals with backticks. So I'm going to paste it in, add a question mark for query parameters, u equals, and this is why we're using a template literal. So we can pull in the values directly inside of here with $ and curly brackets. And I'm going to type in u.value. This is going to be the username, ampersand p equals, and then $ and curly brackets surrounding p.value. All right, that's the username and the password. Whenever we click the page, then it's going to make the request to our attack server, sending it the stolen login information. All right, so let's refresh the page. I'm going to mouse over, and then you can see the form was injected. I'm going to click the page, and then since we have that share modal or the share functionality, like filling the entire page right now, you're going to see this come up. This is just what happens normally when you click the share page. But if we look on our server now, we can see hello and world was stolen from the web page and sent to our attack server. All right. And so this is kind of like, you can see like it's no longer just like some tiny little vulnerability at the very bottom of the page. It's like, think about it. How would you have prioritized this in the beginning? You know, there was a share this page functionality with a bunch of content. And if your data showed that nobody was even clicking that share this page, like if you looked in your analytics, would you consider that a top priority to fix? You know, a lot of people wouldn't, because, you know, it doesn't seem very likely to be exploited. But with the power of JavaScript, you can see that it can cause a lot more damage. Yes, Nicholas has a question.
Hey, Jesse, how are you? Good, thanks. I'm sorry I don't know a whole lot. I'm just beginning coding, but so far I follow what you're doing. I understand it, but it seems to me that everything you're doing would only affect your machine, right?
Yes.
So I can do the same thing on any web page, and I can change, I don't know, the format and things, but that wouldn't affect every user out there unless you do that in the server. Am I correct?
Yeah, so that's a very great question. So does this affect just your local machine, or can it affect other users, other people as well? And so the way this works, this specific example works through the URL. And so the way it would have to work is you would have to send a link to somebody, get them to click it, like in a phishing attack. So you would send somebody an email, maybe targeting their CEO or somebody, one of the admins. They click this link, and then it will go ahead and run in their browser, not in your local browser that you developed it in, but if they click the link, it'll run in their browser. Now think about this from another perspective. Like, this is part of a cross-site scripting vulnerability, and those can get introduced in many ways. It doesn't have to just be in the URL. It can be in a comment. Like if somebody writes a comment, then that comment can run script on the page if it's not protected. And so there are many other ways that they can be run. And so this is just an example from the URL. And you don't even have to have them click a link. What you can do is just redirect them to this website with that payload inside the URL. So imagine if this was on your website, all right? And then you can send a phishing email out, or you can redirect them to this page in order to launch the attack. Does that make sense, Nicholas?
I think so. I mean, if I develop the page and I send a link, I get that. But if I develop this page, right? You develop this page. How can I piggyback of a page that someone else did? I'm thinking of, if I develop a page, how can I protect people? Wouldn't they have to get in my server to put that little code for everyone to be affected?
Yeah, so the problem is the way your server generates the code, so that you normally create a web page from your server, right? Using HTML and whatever framework you might be using. Like you could be using Ruby on Rails or whatever it might be, or React or PHP. And then when you generate this web page, you make it dynamic. You add some kind of user interaction to it. Like for example, adding share this page. We use the URL in order to make that work. Okay, and so what we have now is like the way to fix this is in the server side, you need to escape the user input properly for the context. So like right here, we were injecting inside of the data URL attribute. And the only reason we were able to break out of this is because we have this quote that we injected in here, right here. We injected this quote. This wasn't what was supposed to happen normally. You wanted it to be treated as text, but instead we allowed somebody to make a URL so that they can inject code instead. All right, the way to use that, to protect against that, is to use HTML escaping, like whenever you render the page. And so this is, does that make sense?
So if they can manipulate the URL that I am linking to without me knowing, and that's how they can get to me.
Yeah, because sharing this page is going to share the current URL. And so that's how it works.
Okay.
All right.
Thank you.
You're welcome. Okay, and there is another thing that I want to go over also is, so we have this can be part of a phishing attack, or it can be somebody redirecting. Like if you're on a HTTPS URL and you're using, say, public Wi-Fi, they can always inject some kind of redirect to a vulnerable page like this. And so there's just many ways that you can launch an XSS attack, but really the main things that I usually see are from URLs where we're taking some kind of information and then putting it inside the web page. And so that is able to be modified by attackers if it's not taken care of properly. All right, so from an attacker's point of view, we've got a lot of this done, but this right now, you can see it's really freaking sketchy. Like if a developer sees this, they're gonna see, hey, share this page is now at the top. It's supposed to be at the bottom. So they're gonna investigate this. They're gonna fix this and find that, hey, there's a vulnerability in here. And they're gonna fix the data URL attribute so that attackers can't inject code and they can only inject the URL. Or they can't inject code, but it treats the URL just as text, not as code. And so what we need to do as an attacker is we need to hide all the mess that we made. We need to clean it up. And so how we can do that is first off with some styles. In the very beginning, we made share this page at the very top of the page. So if we just make it invisible, then it's going to fix this problem. So if we just change color to transparent, I'll hit enter, and you can see share this page is no longer there, right? Now let me go to my attack server, and then I'm gonna mouse over. It's going to inject the form. You can see it's still there. And I will click the page. It's going to trigger the share. And then looks like I need to refresh the page in here. All right. And then mouse over, I'll click share. And then it should be injecting our hello world, but I need to fix a few things first. So in order to do this, I need to go back to where we were trying to hide this. All right, so we set the height, we set the color to transparent, and then we have our on mouse over. Okay, so what we need to do next is after we do this, we need to start to clean up kind of the mess that we made in order to fix this. So what we got to do next is let's clear out the styles. So in order to do that, we will have this dot remove attribute style. All right. And then I'm going to refresh the page, mouse over, and you can see now when I click the page, it is not going to trigger that share this page anymore. And so, one second, I'm going to see why my server is not working. Let me inspect really quickly. I've got failed to fetch. Okay, so I messed up my URL right now. And so let me just fix that really quickly because I added something wrong. And let me just, oh, I misspelled HTTPS. I added something in there. All right, so let me refresh the page. All right, now I'm gonna mouse over, it's gonna inject the form, I click the page, and then again, we get our hello world sent back to us properly. And so what we're seeing here is we're starting to get into what's called just self-modifying code. And really it's self-deleting code. So it's code that when we inject it into the page, after it runs, it's going to delete itself so there are no traces left behind. And so what we see next that we need to do is we need to hide this form, just like we hit share this page at the top. And so the way to do that is once we create the form, next we need to set the style on that as well. So f.style equals display none. All right, so we are injecting that. I'm gonna mouse over. You can see now the form is not visible. All right, it's completely invisible to the page, but if I click on here, you see that we're still going to send our hello world to the server, okay? And next thing we need to do is like, right now, everything looks 100% like as it was when we first started on the web page itself. But you can see like if a developer comes in and they're working on a feature, they can see that, you know, there is all this code in here that doesn't belong. And so we need to clean that up as well. So now we're getting more, diving deeper into self-deleting code. And we're going to do the same thing with the style, or we're gonna do the same thing with our event handler, with our attack payload, as we did with the style. So this dot remove attribute on mouse over. And so this is gonna remove on mouse over. So once we mouse over, share this page, which we filled 100%, after it runs the code, it's going to delete it all. All right, so I'll copy that and refresh it. And now when we inspect this, we can see that it's completely gone. So now there are a few things to clean up to make this attack just like absolutely like 100% reliable from an attacker's point of view, as best as we can. A couple things, one of them is that this hash right here it's not supposed to be there because, you know, it's usually just the plain URL. And so that could raise some suspicion, but something more obvious is the URL itself. Like if somebody sees this URL, they're gonna know that something fishy is going on. They're gonna know that, hey, I'm being attacked right now, especially if a developer sees it or somebody who's working on the website. And so what we need to do here is we need to clear out the URL from here, all right? And so the way we do that is we have, as an attacker, we have access to all the tools the developer has within the browser. So how we would do that is we would use the history API. So it's a built-in browser API that we can use to modify history. So we're going to use history.pushState. And the first two URLs we can leave as empty strings. They're not important to us right now. But the third one, this is what we're going to set the URL to. So we're going to do location.pathname. And what this is going to do is going to take the URL as it was in the beginning, and then it's going to cut out all the rest of it that we added from our code. So when we copy this, I also want to change the data URL. So after we update this, we're going to change the data URL so it's back to normal. And so we're going to use that. We're going to do this dot set attribute data dash URL, and the value will just be location. All right, so I'm going to enter, and then you'll see that pay very close attention when I mouse over the page, the URL is going to change. All right, right there. All right, the URL just completely erased itself from, erased all the code that we're using to attack the page. And if I inspect the share element, you can see the data URL also updated. So now there's almost everything has been cleaned up. The last thing remaining is just the form. We have the style as display none. And so again, if a developer is working on this page, they can be inspecting it and then they'll see that potentially, you know, there's this form in there. And so let's remove that also. After we use that in our fetch request, what we need to do is remove it. So just f.remove we can call. And once we do that, refresh the page, mouse over, the URL has been reset. I'm going to inspect, and then, oh, I messed up. So form is still in there, so let me fix that. Okay, so I have f.remove in there. All right, let me Copy this. I'll hit enter, refresh the page. I'll mouse over. Then I'm going to inspect. And the form is still injecting. I need to see why, but you can see that. Oh, is this the same form? Yeah. Okay. So again, we can work through this and figure out what is going on, or if you have questions, then we can continue and I can ask you questions for this. But right now, what we were just looking for is to clean up all the code that we did, and we've gotten almost 100% there. It's just that once we had this resetting going on, we would need to figure out and work with it a little more to see why it is still there. All right. And so, all right, there it goes. All right, so I think I just needed to refresh. I had some weird thing going on, but now you see the form is completely gone from the page. The data URL is 100% reset back to its original position. And the page looks and acts just like it normally would. And if you can see, whenever I were to run this, mouse over and click, we are still receiving the username and password that we stole from earlier. All right. And so with that said, I want you to kind of get the idea that this is more than just XSS. This is more than just, injecting something into a web page. This is like the mindset of an attacker. It's like what they're trying to do is take control of your application and do things they're not supposed to be doing, while at the same time trying to cover their tracks. And if you can see, like, it started off as a tiny little vulnerability on the bottom of the page. And then with just code, we were able to grow it and make it become much, much bigger than it originally seemed. And so whenever you're working with security vulnerabilities, try to think about what's the worst case that can happen. And is that worth the risk of putting it off till later? Or is it worth balancing out, trying to work it into your timeline for whatever features you're trying to develop? All right, so that's all I have for today. Let me know if you have any questions, and then we can go from here with any Q&A that you have. All right, so I'm going to turn it back over to Pete. And thank you for your time. I appreciate it.
Thanks, Jesse. So I have a couple questions.
Yeah.
And I'll keep an eye on chat too, because I'm sure that there's going to be some questions that'll come through. Well, actually, I will. I'm going to go ahead and start with Jay's because it's pretty funny. So he says, one, I'm pretty sure I'm the greatest hacker of all time after this. That's his first comment. Second comment is, how do I hire you to make sure this never happens to me or my company? So
yeah, so you can contact me at Chef Secure. So Jesse at Chef Secure. You can email me if you have any questions or want more. I have an XSS course. Like if that's specifically your problem, then I've worked through just training like people on how it occurs in applications, 100% complete fixes, and then how to prevent it from happening in the future. But yeah, you can contact me, Jesse at chefsecure.com. And you are the greatest hacker in the world after this, Jay.
Nice. Well, hey, so you had mentioned something in the very beginning of the call where hackers have bots and things that are continually going out there and looking at vulnerabilities and pulling that up. What tools are they using to do that? I'm just kind of curious. Yeah,
some of them are like some of our pen testing tools, like Burp Suite's one of the most popular ones. Like it's really good to help find vulnerabilities for both the good guys and the bad guys. But there are custom scripts that they use. There are just all kinds of different tools out there just to find vulnerabilities, because there's a bit of kind of like the middle ground. But there's a hard thing to do. Is what we're trying to do in security is try to stop the attackers from doing these things. But at the same time, we need to empower ourselves. We need to empower developers to be able to find their own vulnerabilities and to be able to stop them. And so we do create tools, but for the most part, like whether or not we created tools, they're going to be creating them on their own. And so they use some of their custom scripts, their custom tools, and others they use just commercial tools as well to find and scan websites.
Right. So you've been doing this for a while, obviously. What's the most, I mean, I love stories, right? So what's the most vulnerable site that you've seen that almost just made you think to yourself, how is this business still in business? You don't have to name names. I'm just more curious. Like, what was like something so astonishing to you that was like, wow, how is this company still around?
Yeah. Yeah, and this is nothing against the company. I'm not going to say the name of the company, but so this company had over $110 million in funding, right? But they had zero security efforts, no security team in the company, and there were thousands of vulnerabilities in there in their application. And so it's just what I found. Like again, that's not against the company because that is actually pretty common, to be honest. Like a lot of companies just aren't aware of it. Because like developers, like there are really smart, incredible developers who like, they just blow my mind, like how smart and how intelligent they are and how great they are at what they do. But they just, a lot of them don't have the fundamentals of security. Like they don't really know what are some of the attacks that can happen. And so it's just a matter of, the problem is education, really. And, universities, only 9% of the nation's top universities, like the best of the best, only 9% require any kind of cybersecurity course to be taken.
And 9%? Is that what you said? 9%?
Yeah.
Wow.
And of those, like even some of those, like it's just the basic, fundamentals of security. It's like, what is encryption? Kind of things like that. And it's not actually teaching developers the skills that they need in order to protect their sites and the users that, they're in charge of protecting.
So that kind of leads me into another follow-up question for you. So you had mentioned that, as a $110 million funding account, right? And that's just not their business, right, of thinking about security.
Yeah.
How have you kind of overcome that from a business perspective? Because I have heard that before,
Yep.
Right? That businesses are concerned, right? I mean, I've also heard a statistic that the chief information security officer is usually the first to go.
Yeah.
Especially when something happens, right? So it's a very interesting kind of skill set to kind of go into and a job into because it's very vulnerable, right? So how have you kind of had those conversations with businesses to have them see it and invest in it?
Like with anything, it's really speaking the language of who you're talking to. Like when I'm talking to developers, I like to talk to them with code. Like I like to show code so they can get that understanding because they're most familiar with code. If I'm talking about like attack tool change, if I'm talking about cyber kill change or whatever it might be, it's like, that doesn't make sense. What the hell is that? And so it's like talking about the theoretical attacks for developers, for business people, for CEOs, CTOs, like talking to them, it's about, what is the cost of a vulnerability? Put it in dollars, put it in money. That directly affects the business. That's what the business cares about. And so with XSS in particular, like, so the average bounty, like we can take averages, average bounty paid to find a security vulnerability and report it. So there are websites like HackerOne, BugCrowd. So they get hackers from all around the world reporting vulnerabilities to websites like Twitter, Facebook, and they get money rewarded for finding those vulnerabilities because they're stopping the bad guys from exploiting them. And so the average, it's over $1,000. Facebook charges a lot more for those. Google pays a lot more. So does Twitter, but average is around $1,000. And so if you think that's just for finding the vulnerability. After you find a vulnerability, then you have to fix it. You have to pull it into your, maybe you're having a sprint. You have to pull it into your time frame of what you're working on currently. And that also involves QA, that involves testing, that involves changing environments for the developers, which, changing context takes a lot from developers in terms of focus and energy and productivity. And so there's also there's the release time. And so it's just adding those up and counting like hours, like a developer would spend doing that, or a QA engineer would spend doing that. You can directly, say like, this is the cost of a vulnerability in terms of just getting it fixed. But that doesn't even come close to talking about, what's the cost of it if it actually got exploited. how would that affect the reputation of the company? Like, what if they actually stole things? What if you got sued in a legal battle? How much would those lawyer fees rack up? And so we're really talking about, what is kind of the worst thing that can happen with that in terms of, monetary value. That I see helps a lot in getting people who aren't focused on 100% on tech or security, like really getting an idea of, how serious this is.
No, that's fantastic.
Yeah.
So I'm going to open it up to everybody. Does anyone else have any questions? You can either put it in chat or kind of unmute yourself. Nothing so far.
All right.
All right. Well, hey, if you want to send me, your contact information, Jesse, I can kind of get it out there to the whole meetup page. And then also, just like you said, connect with you via email, LinkedIn. You're all open for all that stuff.
Yep. All right.
Awesome. All right. Well, cool. Well, thanks for everybody for joining. Jesse, hopefully I'll see you soon when I'm back in Austin. It's been a while since I've been back there. I really miss it a lot. But yeah, I'll be back there soon when things start to open up a little bit.
Cool.
And I'll see you and Jay.
Yep.
So I definitely appreciate it. But thanks again. The recording will be out. We'll probably be putting it up on Friday. It'll be out there for everybody. So definitely check it out on irtalent.com with sessions, and then also on our YouTube page. But we'll be back next week for another session, and then we're going to take a week off. So thank you very much. Jesse, thanks again. Appreciate it. See you soon.
Bye-bye.
Thanks.